Okay, well, hello. We will be showing today a little bit how this web interface, the ChemEd data, works. Uh, just when one loads the first page, one can see that there are 10 boiling points presented in the graph that correspond to the 10 molecules drawn in here. Why are they all alcohols? So the alcohols are selected down here, and the property expressed down here. It's a boiling point. It's selected here. So, however, the selection includes way more molecules. So one can select 25 matches, or even you could select all of them, which is a fair amount of them. And if you want to select them all and plot them, so here you will see the different trends in boiling points of all the molecules that are alcohols. You can also see that as you hover over the graph, you can see what molecule each of the points correspond to, and you can also sort. So I'm not going to select any of them, and I can sort them by number of carbons. So now the molecules are listed as number of carbons. So if I decide to plot them all, one can see that the shortest methanol is on the left, and the longest, I don't know how many carbons, probably 10 or 12, is on the right. You could also decide to sort in molecular weight, in this case from an increasing value or even decreasing value, and you again select it all. Or if this set of data is too overwhelming, you may just want to select, say, 25, and again, so plot all, and you can see how the boiling point changes in molecular weight. Again, you may want to simplify sometimes the sample. For example, you may want to see how the molecular weight changes only with 10 molecules. So you can see here that why there's a diol. The diols seem to have much larger, much higher boiling point. So how about we just show them all, but I'm just interested now in diols. So I can filter all that by writing in here, say that I'm writing diol. So now all the molecules are diols. And I can again plot them all, and again I see the different boiling points of, in this case, of the diol selection. You may want to select other kinds of functional groups. For example, if none is selected, of course the table is empty, but I may want to compare how alkanes and alcohols compare. Again, you may want to sort it by number of carbons, methane, methanol, ethane, ethanol, etc. You can select some. Say I'm just interested in these, and then again plot selected. And these values here are shown on the graph. Maybe boiling point is not something you're interested. You could do melting point, or you could do, say, heat capacity. How about heat capacity for all alkanes and alcohols? And I can sort it by number of carbons, plot selected. Well, of course, if you don't select anything, the plot selected is going to complain. So let's just plot everything that is shown. We can see then that both alcohols and alkanes show different kinds of heat capacity. The idea again is to see, for example, how the importance in boiling point of intermolecular forces. So one could see, for example, that if I sort it by number of carbons and I plot all, alcohols will typically have a much larger boiling point than the corresponding alkanes. However, this trend may not be true for heat capacity. So, for example, if I plot all, again, just still higher, but not as remarkable. Okay. Again, if one is happy with specific selection, say that you want to send it to your students as something, you want to prove a specific trend, specify your selection, say, oh, I'm really interested in this, whatever this trend is showing. You may want to save this selection, okay? And this URL with this stamp will not be erased, and so every time you go back to this URL, you'll be given the specific selection that you saved. So this URL will always now be associated to this four molecules. If you're so happy about these 4 molecules, you again may want to select them all and see them in 3D. Why is it that this heat capacity, but again, if you want to do boiling point, maybe a little bit easier. And let's again, for a simple case, boiling points of alcohols. Why is it that these 3 have the trend that show? So you can click on View 3D, and will pop up a new window with these 3 representations of the 3D structure. Again, you can synchronize mouse, so you can explore a molecular electrostatic map, for example, for all of the molecules. Or if you will, you may want to compare a molecular dipole. In this case, not one dipoles, molecular dipole, etc. In this case, not that the dipole is that different. So, if, just so you know, these all this data has been downloaded from different websites, different databases. You can access to the JSON files that we have access to. So for example, all of these are free to download. Just so you know, they are released under specific license. But that's pretty much the basic functionality of the ChemEd data, at least for organic molecules. Later on, we'll comment on how we can use the inorganic set of molecules. Thank you.